Okay, hi everybody. So in this video here, we're looking at function notation, and we're looking at the the different notations that we use that we see when we're using functions, and making sure that we are interpreting them correctly here. So we're given that f of x is equal to x squared minus 2, and g of x is 1 over the square root of x. Now I want to find this little o there, f of x. Now that's not a filled in dot. That's not multiplication here. Okay, this is composition. This open dot means g of f of x. Okay, so this is a function being substituted inside another function. Now that is not particularly hard to work with. Now conceptually, there's a bit going on here. Okay, because functions turn the given values, the values inside them, the independent value into a dependent value. Well, in this case here, the dependent value for f becomes the independent value for g, which might sound kind of confusing on the face of it here, but ultimately it's not hard to work with. What we're going to do is a substitution. We start on the inside here. So we're going to start with this interior function f of x. Well, I know that f of x is x squared minus 2. So I'm simply going to replace f of x with x squared minus 2. But now we got to be really clear on what function notation is doing. G of x takes whatever's inside the function here, square roots it, and then reciprocates it in a sense. In other words, it puts it 1 over the square root of x. So if I've got, for example, 4, that means I've got 1 over the square root of 4. Okay, if I've got g of let's say a, this is going to be basically the square root of a, and I'm going to divide that into 1. So whatever's inside here gets square rooted, and it gets put in the denominator here. So that's what g does to whatever's within the parentheses behind it. So what's going to happen here is if I have g of x squared minus 2, g is going to put a square root over x squared minus 2, and then it's going to put that into the denominator. That is the expression that I'm looking for here.